Hey everyone, welcome back to the channel. If you're watching this video, you're probably considering diving right into step maths, or maybe just looking to improve your maths skills in general. But this video should be useful for everyone, whether it's GCSE, A-level, degree level, or even higher. Today I'm going to be talking about one of the most underrated skills for mathematicians, and that is how do you actually write like one? You might be wondering, what does it actually mean to write like a mathematician? In that sense, getting quite philosophical here, what does it mean to be a good mathematician? Now, at A-level, you're typically taught how to answer questions just to get the right answer. Just the method, nothing more. What is x? X equals 3. This often leads to scribbles, messy writing, bad formatting, and just, most importantly, just a lack of explanation. While that might work at A-level and GCSE, it's not the approach that will help you succeed when it comes to more advanced mathematics. Being a mathematician isn't just solving problems in a stuffy old office and then filing them away for no one to see. It's about communicating your solutions clearly so that others can follow that reasoning and understand your solution. There's actually a really famous story that comes along with this. Well, it's at least famous in the maths world. It really highlights the importance of this skill. Now, back in the 17th century, a mathematician named Pierre de Fermat posed the problem that the equation a to the power n plus b to the power n equals c to the power n is not solvable for any n greater than 2. Now you might recognise this equation. It's actually Pythagoras' theorem when n equals 2. Fermat then casually wrote in the margin of an arithmetic book that was a copy from, I think, 250 AD, that he had a solution. Great. He then wrote that unfortunately it's too big to fit in the margin, and then guess what? The problem wasn't solved for another 300 years in 1993. Now whether Fermat actually had a solution or not, nobody knows. But imagine if he did, and imagine if he actually gave us a full solution. But since he didn't, mathematicians struggled with this for another few centuries. For a more up-to-date example, consider you're working in a group project where everybody's contributing and you're going to present it at the end of the day. You can all work on it, but if then someone comes out of the blue and says, oh, the answer is 3. Now what do? How do you turn that into a presentable piece that you can explain to someone else? It hasn't been explained to you. How are you meant to understand it and then teach somebody else how to do it? Well, it's not possible. Whereas if your work is clear and well structured, it's much easier for other people to understand your process and then build on top of that. Whether it's in academia, industry, your ability to convey your reasoning can open so many more new doors and opportunities where people can build on other people's work. So what can we really learn from this? Well, writing clearly and thoroughly is really crucial, not just for your own understanding, but for anyone who might read your work. So what are the common pitfalls that students get into? Well, one is writing too much, but the more common one is just writing too little. Some go into excessive details on just minor points, wasting really valuable time in that exam, while others just skip steps that they seem obvious. So the key is to kind of strike a balance between the two. Be thorough, but don't overwhelm your reader with too much detail. This makes your work really difficult to follow. Always keep in mind that the goal is to make the reader's life as easy as possible when they're reading your solutions. Now, onto a practical example. Consider this question. It should be somewhat similar to what you've seen at A-level. Now take your time, read it through thoroughly. Feel free to pause the video and even have a go at it if you want to. But the focus of this video isn't on how to actually solve this, it's about how we should write our answers. So don't worry if you're not sure how to attempt it just yet. Now, I'll give you 3 seconds before I show you an example solution. Okay, so let me show you an example answer where someone, let's say me, has put really no effort into writing well. Now, imagine you're an examiner or a student just trying to learn something from this. Now, I can see where they've started. They've at least labelled it well with the question and the part, and they've clearly labelled the equation correctly. But after this point, I'm starting to get very lost in what they've done. They've wrote some down here, 2 solutions, don't know where they've came from. I assume it's something to do with this writing on the right hand side, but they've not labelled it well, they've not really kept it in line. I can't really tell whether it's rough working or it's part of their final solution. Now, the graph's okay. They've written down the points of interest, but they've not really labelled it. We could do with an X and a Y, could even label the actual graph itself. And then we come to the solution. I'm a bit lost here. They've started with an A, but then the letters have become meaningless. So I can't tell whether they've finished the question or whether they've just kind of given up and just went on to the next part. Now, similarly with the second part, they've quite quickly written things that's not really structured. I'm getting really lost with all these different positions of where the text is. There's this bit on the left-hand side, there's a middle bit, and then there's a right-hand bit. They've also not labelled what they're trying to do, so I don't know why there's 2 graphs instead of just 1, and I don't actually know where the final solution is. Is it this on the right? Is it this on the left? Is it the graph in the middle? I don't know. They've not given us a clear indication of what they're doing. Now, this solution is completely correct. you'd get all your actual answer marks. They've done nothing wrong, but I can't actually read what they're doing. I don't understand it, and it becomes really difficult as a marker to see where I'm giving out the marks. Okay, so how can we improve on this? Let me take you through a bit of a better way to approach this question. Now I'm going to write it out from scratch so you can follow along. And there's a bit of a tip: when you're in an exam setting, you're limited on space and time, so you might want to plan out your answer before you start writing it. Take a minute to kind of outline the approach on maybe just a scrap piece of paper. This will help you avoid like the messy corrections and keep you structured and logical, so you can keep your eye on the bigger picture. Okay, for this question, they want us first to sketch the curve y equals x to the 4 plus 9, minus 6x squared plus 9, sorry. And they want us to work out the coordinates of the stationary points. So first off, we want to know what this curve generally looks like. So we want the general curve shape. And then next, we want to have a look at stationary points. Now, how am I going to get the stationary points? Well, first off, I'm going to need to differentiate. And then find the solutions. And then that's all it needs to be. Just a quick plan on what you're going to do, and you might deviate from this, but it gives you in your head kind of an idea of what you want to do. Okay, so let's actually go to a bit of paper to start the question. Okay, so let's start by writing the actual number of the question. Makes it easy for an examiner to follow up. Okay, so right, we want to start off with writing the equation. For the equation, y equals x to the power 4 minus 6x squared plus 9. Now, what does the actual curve look like? Well, we look at the highest order term, x to the power 4. So, it's a quartic. Now, what does a quartic look like? So, the equation is a quartic. It is a positive quartic because the sign in front of the x to the power 4 is positive. So, which is positive, so has general form, general shape, shall I say, like this. Okay, so that gets us our general shape. Next is to find the stationary points. So to find the stationary points, we want to first differentiate, and I'm going to state that so they know what I'm doing. So y dash equals 4x cubed minus 12x. That's it. The stationary points obviously satisfy that the differential is 0. So that's just y dash equals 0. So therefore we just want to solve 4x cubed minus 12x equals 0. And now you can just go into your maths, you don't need to explain too much more. So just solving this, 4x, x squared minus 3x minus 3 equals 0. Then 4x, x plus root 3, x minus root 3 equals 0. Okay, so we've got so far. Next we want to state what we've actually found here. So the stationary points have x values, x equals 0, x equals root 3, and then x equals minus root 3. Okay, so we've done part of it. We want to find the y coordinates now. So just to do that, all you need to do is plug it in. And then the first one is y equals 0 minus 0 plus 9 equals 9 at x equals 0, y equals 9 minus 6 times 3 plus 9 equals 0 at x equals root 3, y equals 9 minus 6 times 3 plus 9 equals 0 at x equals minus root 3. So we've now got the x and y values, so I'm just going to state what they are. The stationary points have coordinates, and it is 0, 9, root 3, 0, minus root 3, 0. Okay, so we've done all of the steps we set out to do. All that's left to do is actually draw this. So we know the general shape, we know the points it satisfies. All I need to do is actually draw it. So if I call that positive root 3, I'll try and be consistent. 1, 2, 3, 4, 5, 6, 6 along, 1, 2, 3, 4, 5, 6. And then up the top, scales don't need to be super accurate, they only ask for a sketch. So then I'm going to draw this. And then remember to label them all. So it's 0, 9, root 3, 0, minus root 3, 0. With this being the x, this being the y, and just for consistency, I will fully label the graph. Y equals x to the power 4 minus 6x squared plus 9. Okay, and then we've done the first little bit of the question. Okay, now return to the question because we want to consider the next part and we want to create a little plan for this. So they've given us a new equation, which is this, and now we want to consider what the implications of that new equation are. So we want to compare it to the one they gave us originally. So first is compare equations. And the second part is, well, they've asked how many real distinct solutions do we have? Well, if you think about graphing, if I'm looking for distinct real solutions, what is that? That's just what points actually pass through any y value. So I can just consider vertical shifts in that graph. So I'm just going to say consider vertical shifts. And then it's only a short plan, very quick. This is my plan for the next step. Okay, so they want to consider n equals 0, n equals 1, 2, 3, and 4. Now again, I want to set it out neatly. It's not a new part of the question, so I don't need to write a new sentence. But what I want to do is now state what I'm going to do. So first off, I'm going to compare the two equations. So comparing y equals x to the power 4 minus 6x squared plus 9, and y equals x to the power 4 minus 6x squared plus b. Okay, so only difference between them is I have a 9 instead of a b, but what I want to do is try and merge the two together so they look pretty similar. So I'm going to set, and this is where you want to be clear because I'm setting something new, set b equals to 9 plus d. And I only use d to make it more clear. So now the equation becomes y equals x to the power 4 minus 6x squared plus 9 plus d. And now you can see those two equations are very similar. When d equals 0, it's the same equation. And the fact that d equals 0 just helps us a bit more understand the question, because going back to the graph, when d equals 0, that is our graph. As d becomes positive, the graph shifts up, and as d becomes negative, the graph shifts down. So we can imagine the vertical shifts. And then we're just looking for the crossing points on the axis. So now we want to consider all the cases they gave us. So A was, when is there no real solutions? So we want to first state what we're actually saying. There is no real solutions. You can also just say when n equals 0. When, and now we're going to consider this graph. When will there be no real solutions? Well, if the graph moves upwards, then we'll have no real solutions. So whenever D is greater than 0. But we now want to compare, we've created a new variable, but we want to apply it to their variable. So when b is greater than 9. So that's our new condition. Now part B, there is, I'm going to stop there, not finishing my sentence quite yet, because consider the graph. There can never be no real solution, one real solution. If I move it up, there is 0. If I move it down, there's either 2, 4, potentially 3. So there is never one solution. N equals 1. And part C, again, just labeling all of these, make it super clear. There is 2 real solutions. N equals 2 when, I'll stop there for now. Looking back at the graph, when can we have 2 real solutions? Well, we already have 2 real solutions at the minute, but also if I move the graph so far up that the axis becomes up here, then I will have 2 real solutions because I will be past the maximum. So when either d equals 0 or when d is, in the case of this graph, when d is less than -9, because we want to move it down 9. So when b equals 9 or b is less than 0. Again, relating it back to b because that's what they asked for. Part D, there is 3 real solutions. This is where the question gets a bit tricky, but we're not concentrating on that at the minute, we're just concentrating on writing out well. So when can there be 3 real solutions? A lot of people go, oh well, never. But actually there's one little case when it can happen, which is this case here. Right on that edge, you can have 3 real solutions. So that is when we've moved it down exactly 9, i.e. d equals -9. So that is when b equals 0. So we have, when b equals 0, we have 3 solutions. And finally, the last case, there is 4 solutions, 4 real solutions. N equals 4 when, I've also just forgot to write the when from up here. And you can see every answer is written out nearly the same way, so it makes it much easier for an examiner to read. When do we have 4 solutions? Well, we essentially just need our axis to be in the middle somewhere. So it's anywhere between d equals 0 and -9. So when 0 less than d, wrong way around, -9 less than d less than 0. So when 0 less than b less than 9. And then we've answered all 5 parts of that question. And I've made it super clear to the examiner how I've answered those parts. Similarly, at the end, you might want to say something like, hence a statement, just to show what you've actually shown by this question. This question doesn't require it, but if you're trying a proof or something like that, you might want to state hence I have solved this question. Now I'm going to leave the second part of the question to you. So if you want to have a go at it, have a good go at it. It's very similar to the first part, just maybe a bit more difficult, but what I want you to concentrate on is practicing these techniques that we've shown, writing it out clearly so that it's easy to read, so that if you come back to it in 6 months' time, you can read it and understand your solution straight away. By writing in this structured way, you create a solution that doesn't just earn you the marks, but also helps you fully understand the problem, demonstrates that you understand it to the marker. Remember that clarity is key for all of this. So, now that you know the importance of writing about maths, I hope you start implementing these techniques in your own work. Next time you tackle a problem, pay extra attention to how you're presenting your solution. It might feel like a lot of extra effort, but it really is worth it in the long run. Now, if you made it this far into the video, thank you so much for watching. If you found this video helpful, please give it a like and please leave me any comments for what you want in future videos. The feedback you give me really helps shape the channel. I hope you have an amazing day. See you in the next one.